Hello everyone, good day. In this video, we are going to discuss the overview of Kubernetes volumes. If you like this video, please subscribe to eSparks channel and click the bell icon for the latest updates. This is the agenda of this video. We are going to discuss on these topics in this video. Need for volumes. What is the need for volumes? In Kubernetes, every container runs its own processes or the applications. These processes process the application data and they can read and write the data on its own file system, whatever they have processed. We all know pods are ephemeral and it can be deleted and created at any point in time. When the pods are deleted or recreated, the processed data within the containers will also be deleted along with the pods, just like this. We need to find a way to persist the data which are created within the pods. That is why we are going for Kubernetes volumes. Introduction to volumes. A Kubernetes volume can be considered as a directory which is accessible to the containers in a pod. This directory is used to store the container data persistently. With this setup in place, the data processed or created by the containers will be persisted within the volumes. So, when the pod is deleted or restarted or crashed, data within the volume will not be lost. A volume can be created and mounted in multiple containers also, as shown in this picture. Data that are created by container number 2 and container number 3 both will be persisted within these volumes. Also, a pod can use any number of volumes simultaneously. The data that is stored in the volumes can also be reclaimed by other pods. Let us take an example where we have a volume mounted to a pod number 1. So the data generated by pod number 1 will be stored in this volume. Consider that this pod number 1 is deleted and recreated as pod number X. This pod X can consume the same volume used by pod number 1 along with the data created by pod number 1. One point to note here is, how does these volumes gain the underlying storage? How do they get the storage and from where? Let us discuss the same in the next slide. Underlying storage. The underlying storage for the volumes can be provisioned in many ways. It can be provisioned in the local worker node using host path volume type, or it can be provisioned using the native file system technologies like iSCSI, NFS, etc. Storage can be provisioned using third-party storage vendors like ClusterFS, Portworx, Cinder, VMware, and so on. On the other hand, we can also provision storage for the Kubernetes volumes from public cloud vendors like AWS, Google Cloud, Azure, etc. Types of volumes. Based on the nature and mounting, volumes are classified into 3 types. They are persistent volumes, ephemeral volumes, and projected volumes. Persistent volumes. Persistent volumes are the durable storage system in the Kubernetes that outlives the lifecycle of a pod. Data in this category is preserved when a pod crashes or deleted. This is the same type which we have seen in the earlier slides to understand Kubernetes volumes. A persistent volume is a piece of storage and it is treated as like a resource in the cluster, just like a node, pod, deployment, etc. Unlike the traditional volumes, we will have more control on the PV storage system. For example, accessing modes, like how the volume is mounted within the pod, whether it should be mounted with read-only permissions or write permissions or read-only mode, etc. etc. PVs can be provisioned in 2 ways, that is static provisioning and the other one is dynamic provisioning. In static provisioning, the PVs are created manually by the cluster administrator. Here the PVs forms a pool of storage system. As we discussed already, the underlying storage system for the PVs can be from any of the supported vendors or platforms. How can we consume this PV within the pod? That is with the help of persistent volume claims. A persistent volume claim is a request for storage by the user. It is similar to a pod. Pods consume node resources, whereas PVCs consume PV resources. Claims can request for a specific size and access modes too. For example, in static provisioning mode, assume that a 4 GB persistent volume claim request is made. This claim will select the appropriate PV from the available PV pools, which are provisioned already by the administrator. Within the PV pool, 5 GB PV is selected as the appropriate one for a 4 GB PVC claim. Once this is done, the same will be mounted within the pod. Whereas in dynamic provisioning mode, PVs are not already created by the administrator, but it is created on the fly whenever a PVC request is made. Ephemeral volumes. Ephemeral volumes are the one that follows the life cycle of a pod, and they get created and deleted along with the pod. When the pod is deleted, the volume will also get deleted. Applications that don't care about the data persistency across restarts are best suited for ephemeral volumes. Ephemeral storage is used to address the transient needs of a pod where pods don't care about data persistency across restarts. For example, applications uses ephemeral storage for doing operations such as caching, scratch space, and logging. Some applications expect read-only input data to be present in the files like config maps and secrets. These read-only data can be passed into the pods via the ephemeral volumes. With respect to the ephemeral volumes, data within the volume is consumed by the pods and it is not generated or modified by the pods. Types of ephemeral volumes. Kubernetes supports several different kinds of ephemeral volumes for different purposes. First, empty directory volumes. As the name indicates, this volume is empty at the pod startup. Config maps, downward API, secret inject different kinds of Kubernetes configuration data or secret passwords into a pod. CSI ephemeral volumes and generic ephemeral volumes are the special kinds which are supported by Kubernetes storage drivers or plugins. Projected volume. A projected volume maps several existing volume sources into the same directory within the pod. In the case of projected volumes, the volume sources can be config map, secrets, downward API, and secret account token. These are the supported volume sources that can be projected. These individual volumes are projected into the single directory within the pod. So, within the pod's temp directory, we can see all the data of these volume sources, that is, secrets, config maps, downward API, and service account tokens. Well, that's it for this lecture. Thank you from vSparks and thank you for watching this video.